Hello friends, today we will see the Eigen Decomposition and our eigenvalue decomposition. So this is the techniques we are using in the deep learning, which is the simple mathematics technique using the eigenvalues and eigenvectors. So this technique is used in machine learning, artificial intelligence, signal processing, data science, and image processing and control systems. So what are the steps included here? We'll see. So here you can observe it is A is a n by n matrix. So this matrix can be written as PDP inverse. So A is the normal given matrix, P is the matrix whose columns are the eigenvectors of A. So it will come like vector 1, vector 2, like that. So these diagonal matrix, that is eigenvalues. So lambda 1, lambda 2, like that. So P is the inverse of the P. So here the step 1 is you have to use the formula A minus lambda I is equal to 0. You know the value A. If it is a problem, A will be given. So I already you know 1001. So if you substitute this A and I, you will get the values lambda 1 and lambda 2. So in the step 2, we will solve A minus lambda I into x. Already from the previous step, we know what is lambda. So we will substitute the lambda value, A value, and you will get the values x and y, that is v1 and v2 values. So finally you will get like this. So P is equal to v1 v2, and for D lambda 1 lambda 2, diagonals will be lambda 1 lambda 2, like that. So finally we will get in the form A is equal to P dP inverse. So it will rewrite like that. So it will decompose and rewrite like that. We are rewriting like that. So we'll discuss with an example. So for example, A is equal to 4 1 2 3. So in the first step, what we have to use? A minus lambda I. So lambda I is nothing but like lambda 0 0 lambda. So we will minus A minus, that will give 4 minus lambda, 1 will be as it is, 2 will be as it is, and 3 minus lambda. So this you can write as 4 minus lambda into 3 minus lambda minus 2 into 1, 2, that will come as lambda square minus 7 lambda plus 10 is equal to 0, like the equation ax square plus bx plus c. That means, so if you are forming a two components, so these values should be, if you multiply, it should be c, that is 10. If you add, that should be b, that is 7. So lambda minus 5, that condition is satisfied with 5 and 2. So we can write as lambda minus 5 into lambda minus 2. So lambda 1 is 5 and lambda 2 is 2. So next since we know the values of lambdas, so first we will go to the next step, that is to find the eigenvectors. So A minus lambda I into x. So in this case the lambda is 5. So we will substitute that, and for these values we will get v1 as 1 1, and for lambda 2 we will get v2 as 1 minus 2. That we will see how. So lambda A minus lambda is 5, 5i into x is equal to, so that is A as it is 4 1 2 3, and 5i will come as 5 0 0 5. So if you subtract, you will get as minus 1 1 2 minus 2. So first row you can have equation as minus x plus y is equal to 0. So you can take x as 1. In that case, if you substitute that 1 in the place of x, you will get y is equal to 1. So x is 1, so y is 1. So v1 is column matrix 1 1. And in the second case, same a minus, instead of 5 here we will substitute 2. So 4 1 2 3 minus 2 0 0 2 you will get. So if you subtract you will get 2 1 2 1. So first row is 2 1, so 2x plus y you will get, and if we take x is equal to 1, then you will get y is equal to minus 2. So x is equal to 1, so and y is equal to minus 2, you will get V2 as single column matrix 1 minus 2. So the first column will form by the V1 and second column will formed by the V2 in the P matrix. So finally P will get as, so since V1 is 1 1, so 1 1 and V2 is 1 2, 1 minus 2. So D is diagonal, that is 5 0 0 2. So lambda 1 is 5, lambda 2 is 2. So finally you are going to write it as A minus P D inverse. Thank you for listening.